Transformers changed the game, but they have grown. So has their appetite for memory, for compute, for everything. But what if we could keep the brains without the bloat? This is where mixture of recursion comes. Today we are unpacking a bold new architecture that might just let your LLM think smarter without thinking harder. So let's rewind. Transformers are incredible. ChatGPT, Gemini, Claude, they all use them, but there is a trade off. The bigger the model, the more expensive it gets. And that cost, it hits twice, once during training and other at inference. Now researchers have the two main ways of fighting it. One is the parameter sharing, that is reusing the layers, and adaptive computation only works harder when needed. So the challenge, most model only picks one of these, but mixture of recursion or MoR says why not both. So MoR is a recursive transformer. Imagine a single stack of layer reused multiple times, like running your brain's thought process in a loop. Now the twist, MoR does not treat all tokens equally. Instead, it routes each other token through a different number of loops based on how hard it is. Simple word exit early, complex stays longer. This is called token level adaptive recursion, and it's done via something called router. So think of it like your brain saying, this word is easy, skip ahead. That one needed more thought, loop again. So it's smart, right? Now let's break down the router because they are doing the heavy lifting. There are two strategies. Expert choice routing, each recursion blocks selects which tokens to process next. It's like teacher picking their student. Token choice routing, each token decide upfront how many loops it needed. Expert choice is more efficient but harder to train. It needs trick like auxiliary loss to avoid leaking information about future tokens. Token choice is similar but struggle with load balancing. MOR actually support both and they explore these deeply in the paper. Now this is the time where we talk about the KV caching, and because storing all these attention keys value is what kills your memory. MOR uses two innovation here. Recursion wise caching, that is only store KV pair for tokens that are still active, simple and efficient. Recursive KV shading, cache just the first recursion and reuse it across all other. So there is a trade-off. Sharing KV pair can slightly hurt performance but slashes memory need. So you pick what matters more, quality or speed. So now let's talk about the results. The author ran MOR from 135 million to 1.7 billion parameter scale, and the number speaks. Under the same compute budget, MOR beat vanilla transformer in few short tasks, train faster, uses 25% less memory, and boost inference throughput up to 2x. And remember, this is not a model trick, it's an architecture level gain. Best result, expert choice routing plus recursion wise caching, that combo just work. So what makes MOR trick? Team ran ablation study to find out the middle cycle parameter sharing gave the best result. The linear router with sigmoid out observations outperform deep MLP. Simple, which is better. So the coolest part, tokens with more semantic weight like confident or drugs actually route deeper. MoR learns to think deeper about more meaningful words. So what's next? The future direction. The MoR for multimodal vision, speech, video, integrating with sparse execution and quantization, scale up to 10 plus billion parameters. But even as this, MoR is a big leap. True hybrid parameter sharing, adaptive compute, and smart memory. It just does not scale model, it rethinks how they compute. And that's it. It mixture of recursion, a recursive transformer that learns how to deep think per token, and it might just make large model feels like a whole lot bigger. Thank you.